Good evening. So it's 10 p.m., but why not just do a LeetCode? When else are we gonna do them? Okay, next one, still matrix. Okay, start timer. Set matrix zeros. M times n. Okay, if an element is 0, set its entire row and column to zeros. I do remember that I solved this like half a year ago or last year. You must do it in place. Okay, so no copying to another matrix because that would be much easier. In place. If any element is 0, we want that entire row and column to be 0. Okay. Follow up. Straightforward solution using m times n space, probably a bad idea. Is it a bad idea? We're doing it in place. I mean, if we are doing it in place, then we are not using m times n space. Simple improvement uses m plus n space. We want constant space. Okay, let's see. In place and optimally constant space. Okay. Okay, I think I remember something like this. So let's say we had 0 here. If we have a 0 here, that means this column and this row will be 0. And instead of just right away change that row and column to be 0, which will not work because then we're replacing other numbers. We can put, if this was 0, then we can replace this with 0 and that with 0, because that would also mean that this row needs to be 0 and this column needs to be 0. Okay. So we do that for the entire matrix, and then we should know which columns and which rows should be 0 after we have transferred every element that's 0 to the first row and first column. Okay, since we are using the first row and first column to be this kind of helper marker row and column, what if we had a 0 in the first row or the first column? Then that needs to be completely zeroed out as well. So we need to store it somehow. We need to know if there is 0 in the first row and if there's 0 in the first column. Okay, let's try that. So what kind of space are we taking with this solution? I guess we need to store this first row and first column, which actually means m plus n, but still not the best solution. Constant space solution. But wait, I mean, we are not really using an extra row or an extra column. We are just gonna do it in place, so that's not really additional space, right? Yeah, I think so. Okay, let's write this out and make it work first. So we want to see if there's 0 in the first row, see if 0 in the first column, and then we're gonna traverse the rest of the matrix, and every time we see a 0, if this is 0, then we put that and that to be 0. Okay, so that's the algorithm. Let's write it. 0 first row, false. 0 first column, false to start. And now let's traverse for I in range. So we want to look at the first row, or can we do everything in the same loop? Let's try that. Okay, so we have this many rows, and this many columns. So when we are at the first row, oh, I think we need it in here because we need to traverse each column as well. Oh, if we are at the first row, what do? We will traverse all the J's. So if that is 0, then 0 first row is true. What do? Do we need to continue with the rest of the row? I don't think so. No, I think we can just continue, so we don't have to traverse rest of this first row. So if we continue, it will just skip to the next row. Okay. Now first column, if we're at the first column and it's 0, 0 first column is true, and Well, we can't really do any continue. Oh, can we? Okay, we are at column 0. Yeah, we cannot continue because we want to traverse the rest of that row. Okay. Okay, so now we have taken care of 0 first row, 0 first column. So next step would be to transfer the 0 element to the first row and column. If matrix ij is 0, then we want to do two things. Then first row of that column, we set it to 0, and the first column of that row, we also set it to 0. Okay, I think that's all we need to do within there. And now we want to set all these rows and columns to be 0. Okay. So now we have, right now this matrix has all the markers we need of which columns and which rows needs to be completely 0. They're all within the first row and column. That information is in there. So if we have a 0 here after this loop, that means we will put this entire column to be 0. So we need some more loops here for each row. I in. Okay, for each row, if the first elements, we're looking at the first column now, if we find a 0 here, that means we will put this entire row into 0, so that row I needs to turn into 0 completely. Seems very repetitive, but let's make it work first. So we are at row I, and that first element in row I is 0. We now want to put that entire row to be 0. So that should do it. Okay, then we do similar logic for columns. Okay, so for, let's say for J, So we're looking at the first row now. So first row, column is column index j. For each of these elements in the first row, if we have a 0 element, then we want to put that entire column to be 0. So this will be column different row index. I think that should do it. Okay. What else do we need to do? If the first row has a 0, then we also want to present that. Oh, I see. Very easy to miss, but we are starting from. Okay, so in here we are looking at the first column. We are looking at the first column, and then we are changing that entire row to be 0. So we need to make sure that is not changing the first row, because we still need that for the next loop. We need to reserve that. So this I needs to start from 1, cannot start from 0. So we're looking at from index 1 all the way down. We cannot look at that. We cannot change out of these two zeros. Okay, so this should be the same thing when we're doing first row. So now we have looked at all of these and all of those. So we should have changed accordingly inside here. Now we want to go back and look at these two variables. If there is any true, then we need to set that row or column to 0 as well. Can we somehow put that inside these two loops so we don't have to write another two loops, which is repetitive? If so we want to do that after we have done everything there. It cannot be in the middle or before. Well, I mean, what we need is this. If the first row is, if 0 first row is true, which means there is a 0 in the first row, then we just want to turn everything in the first row to be 0. And similarly for each row in matrix. Okay, so that is what I'm thinking. Oh, it's already taken 20 minutes. Wrong answer. Let's see. What do we get now? 3. So these two did not become 0. Did I make some mistakes here? 0 first row, then first row be 0. If I continue, okay, so first element we have I, J. They are both 0 right now, and matrix IJ is 0. So what happens is we go in here, we set first row to be true, and then we simply continued. So then we had 0, 1 instead. So 0, 1. Okay, so the problem is it was never able to come in here and also mark 0 first column to be true, which is why this did not turn to 0. Okay, so I mean we can add an extra logic, but that seems tedious as well. Or what if we just skip continue? Then we wouldn't miss the 0 first column. Okay, I am glad that it worked and it is very efficient, both in runtime and in memory. I'm pretty happy about that. Okay. Maybe we can manage to keep this video within 30 minutes. Alright, okay, let's do time and space complexity. So the goal is to find this constant space solution, which I do think this is because we are using 1, 2 variables. We are using ij everywhere, more ij everywhere, but we are not using any additional space because we are just changing everything in place. We are modifying the original matrix. So I do think this is a constant space solution, which is great. Okay, time-wise, let's look at time. How many times are we traversing this matrix? Well, it's at least linear. It cannot be less than linear. So first we are going over the entire matrix. We look at the first row, we look at the first column, we look at everything. So that is linear. And then we look at this first row and column that we have processed. And each time we see a 0, we need to go and make that whole row or column to be 0. So that could be at most linear as well. In the case that it's all 0, then we go and do zeros everywhere. So linear, linear, linear. Last part will just be, so we're looking at the first row, if we had any 0 there, then we just make the first row to be 0. So that's just m plus n. So in total, this is gonna be linear in time and constant in space. So that's pretty good. Let's have a quick look here. Top down and bottom up. Huh. Wow, that is very short. That's so impressive because I'm using these many loops. Okay, so we are doing use matrix element to set states in a top-down way, bottom-up way. Okay, for each row, so this is if we have a 0 in the first column, and then we go look at starting from the second column. If we have a 0, then what do? We set that corresponding, we set them just as we're doing here. We're setting them to 0. Now the second part, starting from the last row going back, and starting from last column. So starting from the right bottom corner, if we have, okay, oh I see, first column. So first loop, it's doing the same thing as we are doing, but the second loop is gonna like swipe it in one round and then put everything into 0 where it should be, instead of doing it separately like I'm doing here, setting all rows to 0, then call columns and then look at first row and first column. So instead, that solution will just be starting from here, and they will look, is that one 0 or that one 0? If yes, then that's 0. And then we'll go backwards, and let's say going backwards, let's say the same row backwards here, is that one or that one 0? Then we set it to 0, and then we do this. So last row we do everything like this, and then second to the last row, then we do everything like this. I think, okay, let's see. Starting from the last row, going back, and then the next last row, then going back. And this step is, if we had any 0 in the first column, then we also want to set that yes, we also want to set that to 0. So interestingly, it only needs one of these. So I'm using 2 to mark if there's 0 in the first row and 0 in the first column. So here it only needs one variable to mark if there is 0 in the first column. So what about the first row? Let's see what happens in the first row. When I is 0, then we're looking at right, yeah, so that works out. Yes, very elegant and smart. Always so many brilliant ideas from these super smart people. Okay, so I think that's it for this one. I will see you again later. All right.